Hey everybody, it's Mr. Carr again. Today we're going to be looking at graphing linear inequalities. So yes, last lesson we talked about graphing linear functions or linear equations. Now we're going to do linear inequalities. So with linear inequalities, we actually have more than one variable as part of our inequality. So in this first problem, I'm going to check which of these answers are a solution. To be a solution, we just need to simply plug them in and see what comes out to a true statement. So for example, if I take, whoops, come back here. Okay, if I take 3 times 6 plus 4 times a negative 3, is that greater than 8? So that's 18 minus 12 greater than 8. 6 is greater than 8. That is a no. So A is not a solution. Let's try 0, 2. Is 3 times 0 plus 4 times 2 greater than 8? So 3 times 0 is 0. We got 8 greater than 8. That is also a no. So B is not a solution. It's not greater than or equal to. It's greater than. For C, we got 3 times a negative 2 plus 4 times a negative 1. Is that greater than 8? So negative 6 plus a negative 4 greater than 8. Negative 10 greater than 8. That's a no. So no good there either. Let's see if the last one comes out. We got 3 times a negative 3 plus 4 times 5. Is that greater than 8? That's a negative 9 plus 20 greater than 8. That is 11 greater than 8, and that's a yes. So we have only one solution here. Now, before we get to the actual graphing of these linear inequalities, I could change this a little bit and still come up to a true answer. For example, if I change this from a negative 3 to a 0, that would have been 0 times 3 is 0, and that's 4 times 5 is 20, and 20 would be greater than that. Try to imagine what this looks like. Where is negative 3, 5 compared to 0, 5? Okay, like that. Okay, well, you can't see that one as well. Where are those 2 points compared to each other? Negative 3, 5 and 0, 5. Okay, so we get a lot of different options here versus just a straight number line going left and right. So what we're going to see is linear inequalities as like a two-dimensional inequality. Here's how our basic setup is going to start. If I do this as y is greater than or equal to negative 2x plus 3, I treat it like the equation negative 2x plus 3, meaning I do my y-intercept, which is a positive 3 in this case, negative 2 for my rise over run, so that's up to the left one, down to the right one, and so on. Okay? With this graph, because it's greater than or equal to, our rule here is going to be a solid line. Okay? So if it's less than or equal to or greater than or equal to, it's a solid line. Then I need to figure out what is technically greater than this. For me, I can take a guess that I feel pretty good that greater than this makes it feel like I'm going to go above the line over here. That's what I think is greater than that. But let's say I don't really know for sure. Let's test something. And let's test something very easy, like 0, 0. If I plug in 0, is 0 greater than or equal to negative 2 times 0 plus 3? So is 0 greater than or equal to 3? No, that's false. That means this is not a part of the solution, which means if that is not part of the solution, everything that's on the same side of that line is also not part of the solution. So my actual solution is what my initial guess was. I'm going to shade everything that's on this side of the line. Okay. I guess technically I should probably draw this out a little bit further, like so. So it's everything on that side of the line. Okay. When I go to the next one, we're going to do the same thing. I'm going to graph the line y equals 1/2 x minus 1. So I'm going to start with a minus 1. Positive 1 over 2 is going to go up 1 to the right 2. I'll just do that a bunch here so I can have a nice long line. But here we're going to have our first difference. Doing all that the same, it's a less than symbol. If we are going to do less than or greater than, we actually have to do this as a dashed line. Remember, less than or greater than means you cannot include anything that's on the line, is what we're saying. So if I had something that worked out to like -1 is less than -1, doesn't help. That doesn't count. So that means I'm going to do a dashed line to demonstrate this. Okay, so again, a big difference here with a solid line. Everything that's on the line is a solution. Everything on a dash line, not a solution. Same thing as before, I can take a good guess. Less than tells me I'm going to go down. But if I want to be absolutely sure, I'm going to plug in like 0, 0 and test that out. So is 0 less than 1/2 times 0 minus 1? Is 0 less than -1? No, not a solution, which means we shade the opposite side. That's all my solution there. Okay. Got a couple others. We can still do our inequalities, even though if it's one variable. Think about what these boundary lines look like. When we talked about this before, if I look at y equals -1 and x equals 3, well, if y equals -1, that is going to go down 1, and it's a greater than symbol, so I'm going to do a dashed line that's a horizontal line. That's my boundary line here. If it's greater than that, I think this is more clear. It's everything that's above the line. So if we're just going in terms of y, we know it's up. For the next one, x is less than or equal to, so we know it's going to go to the left of 3. So I can go 1, 2, 3 here, draw my solid line. And scan, come down here a little bit more. It's add a little bit extra. Okay. And if it's less than or equal to that, that means it's going to be everything on this side. Okay. So let's do one more inequality. Graph this one, 5x minus 2y is greater than 4. A couple ways you can do it, just like with our graphing before. You can either plug in x and y values, like x and y intercepts. That doesn't work as well here. So I'm going to transform it. So I'm going to subtract 5x to both sides. -2y is greater than -5x plus 4. I'm going to divide everything by a -2. Just like before, with dividing by a negative, we're going to flip that symbol to a less than now. That's a negative divided by a negative, which is a 5/2x, and then -2. Graphing that, I'm going to go down 2 to start. Positive 5/2, so it's going to go 1, 2, 3, 4, 5, and then 2 to the right. And I can also go down and to the left. So 1, 2, 3, 4, 5, and 2. Since it's a less than symbol, we're going to do a dashed line. So again, if you have this one, I think it's pretty clear where you're going to graph it. But if you have trouble with that, pick something, a test value that's not on the line. That's the other key I should have mentioned. Don't put anything on don't pick a value that's on the line. It's got to be off. So if I try 0, 0, and I test in the original inequality, does 5 times 0 minus 2 times 0, is that greater than 4? Well, those are both zeros. Is 0 greater than 4? That's false. So we know it's not a solution here. So this is only my solution is on this side of the line. Okay. So again, graphing our linear inequalities, that is going to be it for today. That is a quick reminder. You are going to graph it just like a regular linear equation, but we have to do either a dashed line or a solid line, depending on our symbol. And we have to shade a region that's related to our solutions. I like doing a test value. It makes it absolutely clear. So you can always do that. Otherwise, it's pretty intuitive as well. All right. That's it for today. Take care, everyone.